Hi and welcome to DCO. My name is David Copete. In today's video, I'll be going over this design. Now, the idea was to continue with some of the exploration of old school architecture and seeing how we can take some of those concepts and apply them to a parametric model like the ones you see here. Now, I won't be adding all of the details that you see in this design, but we'll be starting by creating the base geometry, which is going to be a polygon, then moving on to creating the dome, the columns, and adding a few details that can get us started with this. So the purpose of this is to share with you exercises, techniques, and a few different things that can help you get closer to learning how parametric design works. So if you would like to download the script, check out the website, copetidavid.com. You can download this completely for free. But with that being said, thank you very much for being here, and let's jump right in. All right, so the first thing we need to do is bring in a parametric point. So we'll go here to construct point, and this will give us a parametric point that is located at 0, 0, 0. Now we can use this one straight out, or we can use a point component. And the reason why I do this is to be able to change the location of your script. So you can right click, set one point, and move it to a different location. So this point we'll be using to start the whole design, which is based off of a polygon. So if we look at our base shape, this is going to be an octagon. But the cool thing about the parametric script is that we can change how many subdivisions we have. With that being the case, we will start with an 8. So we'll go here to polyline or polygon. We'll use a point as the plane input, which means that it will be created at the world XY, which is at the origin point here. Now the radius, let's give it a value. So we'll go to 15.50. This way I have a slider from 0 to 100, and it gives me 2 decimal points. So now we can change the size of your design. Next, the segments. So this, by default, your components will have default numbers. So the radius is going to be 0, but the segment is 6. So let's change that to 8. So that way, or actually let's create a custom slider, because technically you can't subdivide anything smaller than 3. So we'll go double click, we'll go 3 less than 8 less than 20. So it'll be a slider that can be starting at 3, ending at 20, and set at 8. So now let's plug this into the segments. Now notice that, and this is more something that I like to do, is align one of these. Let's see if this works. Align this one, but I want it to be rotated so that this face is actually aligned here. And so the octagon would be more like this. So with that being said, how would I go about doing that? Well, we have a subdivision of 8, so we know how many degrees you need to rotate this to create 8. Let me show you what I mean. When you have a polygon, it's based off of 360 degrees, because that's how many degrees are in a circle. So if you do 360 degrees, which is a circle, divided by, which is /, you'll get an empty division component. Now the B is going to be 8. Why? Because it's 360 divided by 8 for the octagon. Now we have 45 degrees. And all we need to do is take that number and divide it by 2. And the reason why is because this is going to be 45. And if you rotate it by 45, it's just going to rotate it one segment. So it'll be 45 divided by 2. So with that, let's do that. Let's go in here, take this number, and first, actually, I'll show you how it doesn't work when you do this without it. We'll rotate this polygon relative to this point. That's a plane input. And the angle is going to be, first of all, we need to change it to degrees. So notice it already rotates it by 0.5 pi. And then here, we'll plug it in. Now it rotated it 180, or it rotated it by one segment. So if we divide by 2, notice that it rotates it halfway. And now this segment is always aligned with your left viewport, which is here, or your right or left. And so you can develop this module and rotate it around. And when we change the number of subdivisions, we see that that face is always perpendicular to the, what is that, the X direction. So with that, now we have the ability to develop this further. So with this, let's move on to creating the beam that goes above. Now at this stage, there are different directions we can take it. Depending on how you want to develop this, you would take a different approach. And let me explain what I mean. If we want the outside dimension, whatever this is, to be consistent, then we want to offset to the inside. Now, in other cases, you don't care about the overall size. You just have the base geometry and you can offset to the outside and to the inside, which means that it's going to be larger than your base geometry. So depending on what approach you want to take on this one, I think we're going to offset it to the inside so that this polygon number is the actual outside face of wall size. And I'll show you that. So let's do that. We'll take this and we will offset twice. Offset curve. Now notice that it's offsetting to the outside. So we have to bring in a negative component and then another number. So 1.5, or let's do 0.500. That gives me a slider from 0 to 1, sets it at 0.5. And now if this is what I want to offset it again, now if you're only trying to do it twice, you can use this trick, which is just copy this and plug this one into this one, and it will offset this one again by the same amount. This way, this becomes your center line, and that's where your beams and your columns are located. And then the original and this one are going to become the outside face of beam, which would be the outside face of the shape of the design. So we'll move this down, bring in boundary surfaces, plug both of these in, and if you notice that they overlap, then if you flatten the input, it'll fix that. All right, next, well, you got the beam. We can change the size. And if we look at our reference images, we do have a beam here. Now also, see, maybe I can put this in the top view so it's not distorted. Also notice that the outlookers are coming out of the beam. So there's a beam and then there's like an additional portion that goes down, and it's like the decorative part. So let's go back here and let's move this up, because the beam is going to be located at some location above the ground. So we'll bring in the move component, unit Z, because we're going to be moving it up. And now we can tell it what size. So we'll go here. A minimum is going to be 6, less than 12, less than 15.50. So this will be at 12. And now we'll disable the preview on that surface down there. And next we're going to extrude this up. So extrude in the Z direction. But notice that this one's going to be too big. So we need to bring in a new slider. We'll go 1.25 less than 1 less than 2.00. Now we can change the depth of that beam. Maybe 2 is just too little. We'll go 5. And so we can, move this up and down. And if we go back and add more. Okay, so I'm disabling the preview on things that are overlapping because the only thing that we've created here at the end in terms of a solid form is the beam. Now next, we're going to be creating the columns. Now let's take a look at that. Now these columns, we're going to simplify them. Now, when you look at this, obviously there's all of this like detail up here, but the reality is that it's a column holding up the beam. And so that's the simple shape. First is going down here, figuring out which one is the mid one, which is going to be the second offset. And now we can bring in a component called discontinuity, which will let us extract the points where the curve turns and they won't be overlapping. So if we plug it into here, we should have 8 points because we have 8 subdivisions, and use those points as the location for a circle or a cylinder. Now, they both lead you in the same direction, but sometimes when you have a circle, you actually have the ability to use that circle to like subdivide it into points and do other things. So I do like to start with the circle and then use the points as the plane input. And the radius, well, we can change that. We'll go 0.1 less than 1 less than 2.00. Now, here's the interesting part about this, is that even though that is the center point, notice that it tends here at the corner to overhang on the outside before the inside. That's just because of the geometry, how that works, but we just want to make sure that it's less. Now to turn those into solids, we'll bring in boundary surfaces. And we'll extrude it by the same amount as what we moved up the surface by. So if we see this surface was moved up here, well, we can just take this, slide it down, tap Alt, and just use this as the input now. Except for that's smooth. So we need to extrude this up in the Z direction. So let's check out what happens when we change this. 3 is the minimum, and then 8 is what our reference is. All right, so let's move on to the next step, which is going to be to create the dome. Now, if we look at the dome here, we'll notice that it's smooth shape. So it doesn't necessarily have the facets that the shape of the form has, the base form. So it's going to be a smooth dome. Now there's also some details here. I'm not really sure what's going on there. So for now, let's start by bringing up the geometry here. So we'll go to our polygon, our mid one, and bring it up to the top. So to do that, we'll bring in a move component. Bring it up by 12 plus 3.31. So we can add vectors by adding this vector plus this vector, and we can hide hide the wires so they're not just overlapping. And then here, use that as the input. So we moved it up here and then moved it up here again. So now here, we can bring in discontinuity again to extract the points. And now where those points are located, we can bring in another component called circle fit. This takes the points that you plug in and it fits a circle around it. Now notice this, that wherever those points are, you're actually overhanging with the circle. So this is where this offset becomes more critical. So if we offset this by more than one, we'll make 2. You'll see that there's a point in which it actually sits within it. Let's see what number that would be. Just do 1.2. Now here's the question that I have when I'm looking at this. I am not sure what happens here. So this is more of our call here. Is this a full dome that has this thing on top? Or is it a dome that is pointed? I don't know. And the reason why I say that is because depending on what approach you take, you would come up with a different result. So on this one, I'm actually going to be creating 3 points, creating a line segment, and revolving it around the center. So let's do that. Let's take this circle. Let's bring in endpoints of the circle, which gives us a point here. Notice that this is actually 180 degrees from where our module is, but that's okay. So now let's take this and let's also bring in the center of the circle. So if we bring in an area component, the other way is actually using, and the reason why I don't like using the area component is because between Rhino 8 and between Rhino 7 and Rhino 8, there's a discrepancy with this centroid and with this area component. So sometimes I end up using average, which will take all the points and average them to the center. So I would rather use the average and this one. So now we can use an arc here to create the dome, or we can also take this endpoint or the start point, move it up in the Z direction using, let's say 1.5, or try that again, 1.5. So the start point is here, the second point's there, and the third point is going to be this one. So I copied the move up because now we're going to be moving this one up, but by more. If that was 10, 20 is going to be the max. So now we have 3 points, which is all we need for an arc. You'll see this one, the top one, and the start point. Now, depending on what approach you want to take, we could use interpolated or NURBS curve. Let's go to the start point, then the one that moved up, then the last one. So notice now that we have a line segment that has been moved up by using these points. All right, so I'll make this one 8, this one 12. And now we're going to revolve this. Now, you can also use sweep, but for sweep, sometimes you have other issues. So on this exercise, I'll use this one, this point, and this point to create an axis. And an axis is nothing more than a line segment. So we'll start at the center of the bottom of the dome and to the top of the center of the dome, and use this to revolve using this axis and this curve. But now, the only thing that's weird about this is that this is in orange, which means that the degree must be less than the number of sub-control. So if we change this to degrees, we'll leave it at 2. Now notice that we can change the shape and size of the dome. And the cool thing is that all of these are still live. Now notice this, the more subdivisions you have, and it makes sense because the more subdivisions you have, the closer you are to a circle, which means that the dome, which is a circle or a sphere, is going to be closer. And so if you have less, so if you have less than 8, then we start having like, okay, now the dome is overhanging. So I think for now, we'll leave it here, but just keep that in mind. Also, when creating a dome, it goes to a point, and that also becomes very tricky for you to compute. So here's one of the things that I like to do is bring in the extend component, which we'll be using it for the opposite. We'll shorten it. So we'll go here to 0 for the endpoint or for the start point. And for the endpoint, we'll just go 1.5. Notice that it's extending it, so we'll go negative. Now we can make it shorter and use that as the curve to revolve. So we have the ability to change the opening. And this makes it a lot easier for us to take this dome and give it some depth. So if we know that this is the location of the dome, we can turn this. There's 2 ways to do this. Actually, there's so many different ways to do this, but let me show you what I mean. We can use this dome and offset it and turn it into a solid. So if we offset surface in the negative direction and use a value like 1.5. Notice that it offsets to the inside. And now that it's offset to the inside, we can now see where it sits. Now, at some point, it'll go too far. We want to make sure that it bears within the beam. But once it does, then we can do this. Loft between this one and this one. Now, it's not going to work because this wants to be 0, and this one is going to be 1.6. And now, since they're both offset here, I think they should loft. Okay, they didn't loft. All right, the other way is getting the edges. So B-rep edges on this one. This is the naked curve. This is the naked curve, which is the top one. We'll do the same thing for the bottom one, and then loft them together. This one, this one. Notice that it's not going to work until we graft it. Let's see here. So if I disable the preview on this stuff, you'll see that we have the bottom of the dome, we have the top of the dome here. So now if we join it together using both offsets and the new loft, you'll see that we have now 4 different values, but if we flatten the input, that's one close B-rep. So this turns it into a solid. Now the other way of doing this, and I'll show you this just to show you also here, that with the script, you can take different approaches and just not preview them. So for now, we'll disable the preview on this and go back to our base geometry here. Now, for this one, we can also do offset. We're going to offset to the inside. And join these two using endpoints. So holding down shift, we can add 2 and then polyline to close those 2 segments off. So these 2, including this one and the original. So join, curves, and holding down shift, I can add more inputs and then hide the wires so they don't overlap. And we can also revolve this. So if we go here to this one, because notice that all of this was done before this. So now we can take this, copy it, unplug the original curve, and now plug this one in. Now we'll flatten the input here and take a look at this one. So what's the difference? It's the approach that you take. This one was offsetting a curve, turning it into a closed curve, and then sweeping it. The other one was bringing in a surface, offsetting the surface, and joining the 2 surfaces together. So looking at this, which approach would you think it's better? I don't know, it's up to you. Oh, here we offset. So we were sharing this slider. Now I can delete this. And so this is the option that we're taking. And that's the cool thing about parametric design, is that you always have the work and you can always change your mind if you didn't like the approach that you took originally. So now if we take a look at everything here, we've started basically with the polygon, right? And from that polygon, using the geometry that we already have, subdividing it further and creating some columns, beam, and then the dome here at the end. And you'll see here, this is where the issue happens, right? Where you offset this here and offset this here, and then they kind of has a negative number. So using this might actually be just a little bit easier. All right, so let's go back to our reference. Now we could get lost in adding a lot of these details, but I think the next portion, I think that's going to be, for the most part, what concludes this tutorial is this. Let's create this overhang and then see if we can create the outlookers, but notice that the outlookers have this other roof below it. So it's like this column outlooker and then a beam, and then it supports that roof. All right, so let's go back to our polygon, which should be here. Now notice that this polygon is actually not the right one. We actually need to bring in the one before, which is this one, the outside one. So what we need to do is to move that up the same way that this one's moved up. So I'll take this, slide it down, tap Alt, and now instead of moving the middle one up, I'll be moving the original rotated one up. Now here, we can take this polyline, offset it to the outside, and then let's use the slider. Now notice, and let's see if in one of these other images, this overhang does not go lower than the beam. So if we look at the beam size, and it's 3.31, then we can use this number and move it down. So negative, use this. And now we can disable the preview. Those, and on this one. So now loft between this one, and flatten the input. Now the only thing that I see is how this is organized. It looks like this segment corresponds with that one, and so we need to shift how this is. So to do that, here's the approach. When you have this and it's rotated by a whole segment, can we rotate it using the same number but not halfway? So if we go this way, just want to see if this works. What it is this one was with that one, and so we're rotating it by a full step back to getting it clean. Now this, obviously, if it changes, and the number of 3 is just a little bit too low, this number. So I'll copy it, use this slider, and then this one back. Now, how did they angle it? Yep, it looks like this beam just goes way up more. So let's try that. Yep. All right, let's offset this more. All right, now we're going to take these and extrude them down. So let's see. Actually, we may move these down first. So move this down in the Z direction. Negative. Do 1.5 to see how far down that brings it. And then take this and extrude it down. So extrude, negative, Z, and a slider. So now I'll disable the preview on this one. Take a look here. And technically, okay, and I think this is also how they, obviously how they build it. They don't do them all at once. You can create one module, and I think you see this here. You create one module and you just copy it over and over again. So that's something else that we can do here, is rather than creating all of these all at once, which is possible here, we could also just create one and then rotate it all the way around. So keep that in mind. Now the outlookers are going to be an interesting approach, and you'll see why. So here we have this. Which we move down. Okay. So this polyline gets moved down. So I'm copying the move, using that as the input, then bringing it down again, because if this is the number plus the depth of the roof, actually have to use the vector. So we're adding vectors here. Now we have this one plus this one, but it's supposed to be in the negative. So let's add negative vector, and then it should work. Okay, I don't have to do that. Okay, so now we're going to offset this by 2, but divided by 2. So whatever this is, divide by 2. Bring this down as well. So disable the preview, hide the preview. Okay, now that we brought both of these down, now this one has to be brought down again to let's see, we have this here by this one. And this one, top one, needs to be brought down by this. So now we have the original and this one, which we can loft together. Now, I also need to bring this one down, and you'll see why. So we have three, and I'll do it this way. We have three different polylines that are going to be lofted together to create a solid. Let me show you what I mean. This one, and this one. So that one and that one flatten. Oh, it's rotated. That's going to be an issue. So maybe this approach won't work on that one. So let's go back. Go back. All right, I think I got the approach that I want to take. So check this one out. We're going to take the original overhang and move it down by the same amount as we extruded it. So we'll take this, tap Alt to copy it. We will be using the same input as that one, but moving it down instead of extruding it, but moving it. Now here, we're going to be extruding. So we have the roof here. I'll group that so we know that that's it. Now we can take these and extrude them down again by a different amount. So notice that I'm just copying that extrusion and doing it again, but for the new one that I moved down. Okay. Now here, I do want to do something else. Now that we have that, let's go back to our curves. This one, we'll be taking that and offsetting it again, but by less. Then this and this will create a surface. So boundary surfaces between this one and this one. And I'll flatten the input so we only get that ribbon. Now let's extrude this down. So extrude component in the negative direction or down by the same amount as this, but we can actually use a whatever number because this is something that's going to overlap and we can use as a Boolean intersection. So as long as it goes past it, where this intersects with this, here it's called solid intersection between this and this. All right, so what I've done here is create this little beam here. What is this used for? Well, like I said, it's the outlookers. See how far out you want them to go. Okay. And now we need to create some line segments that are going to intersect with that. So for that, let's go back to our circle. this one, but discontinuity and then circle here. Okay. Now we're going to take the circle and offset it to the outside. Now you could use other geometries. I'm just using this one and I'm doing 10.0. Okay, so now we have these two circles. We're going to move this down, hide the display, and then offset this by 0. We have 0, and then here we have this one. Actually, we don't need the inside one, and you'll see why. Because we'll bring in an area component, even though I don't necessarily like using it. We'll be using the average one, and we'll be dividing it. Divide curve. Now we'll be connecting the line segments between my start point, and these will be the endpoints. Now, the more divisions we have, we can also do a multiplier, right? So if, let's say, we'll do 8, 16, just 24 here. So now all of these line segments are going to intersect with that, but the way that I like to do this is this. Offset, positive and negative. So offset this one by 0.125 in the negative direction and in the positive direction. So this one's positive, this one's going to be negative. And now they get lofted together. And then region union. And flatten the input to make sure that it all becomes one. Here's why. Because we're going to extrude this down as a solid. We'll go to boundary surfaces, creating a surface so then we could extrude it as a solid. Now we'll go this one down by the same amount as this. So now notice that we have this overlapping with this, which now we can use solid intersection. What we want to keep and what we want to remove, or what we don't want but we are overlapping. So all of this was to show you a technique where we're dividing stuff and overlapping geometry to create new designs here. Now, are these the best looking outlookers? I don't think so. I actually feel like if they were triangulated, they would be better. But for now, we'll leave those. We'll move on to the next part. Now, this one is subdivided by 24. So there's 3 in each. If you do 24 times 2, so if we do 48, there's going to be 6 in each. And the more you do, well, let's see here if we can offset this by less. All right. I think for the last thing that we're going to do is just add a little bit more detail but to the columns. Now, we have not gone into this kind of stuff, which we can definitely do. But what I want to show you is how to add this detail to the columns. And the reason why is because it's actually a pretty useful technique. And the fun thing about this is that we know we have our circles here, or our columns. And we know we want to give it the detail that we see here. Now these are indentations. We can also make them not indented. We can make them coming out. So what we need to do is take a circle, divide it using divide curve. This is where we could do it to one and not to all of them at once, because it makes it more laggy rather than making a module and copying it around. But let's do it to all of them at once. So the circles get divided using count. Count is already at 10. So if we went to, let's say 8, kind of be consistent. And then in the points, we'll go to circle. And the radius will have to be small because we're talking about like the detail inside of the column here. And if we want more divisions, that's yeah. And now with this, using region difference, we can subtract from the circles and graft these as well. And now these will become the surfaces that get extruded. So it gets kind of tricky to see. So let's do this. Let's go and add some color to it so you can see exactly what I mean. Custom preview and color picker. This will be the dome. And I do like to hide the wire. Tap Alt, beat this copy here. All right, let's see what's next. This one. Column are next. So notice that when you interject, you do have to shift over all of this stuff. Now I know that if you hold down Alt and you move this over, you can space about, but I don't use that as much. Now let's go to columns. And also, I mean, we can also just have two options. We'll just use this one and copy this. All right, so now you're seeing all of the detail here. Now, for me, the things that would be next are adding the details that we see here. The outlookers, I would probably take a different approach. But for now, the cool thing about this is you'll notice that using a script, we have the ability to interject anywhere in the design and add more detail, and therefore help you in the sense that when you create one design, you're not stuck with just one static design. We can come back here, say, you know what, I want this to be 10-sided. And so also, we want this to be very large. We don't want it to just be a small pavilion. We can do that. Now, of course, we need to adjust some of the sliders for the, let's go here to redo. Here, I'll just go back to where we were. Now, what I'm going to do now is clean this up, and I'll have it available on my website. Please let me know what you think about this. I definitely want to go back in here and add more details and continue with the exploration of creating these parametric designs with the concepts and designs of architecture from the past. Because I feel like these designs, there's actually a lot of things that we can learn from. And at the same time, we can learn some cool things like parametric tools. So thank you very much for being here. Check out the website if you want to download this completely for free for a limited time. If you want to support my work, you could also do that there. Otherwise, thank you very much for being here. Really appreciate the support, and I hope to see you on the next one.